Welcome to yet another exciting educational video brought to you by Christ-like Tutors. So today we'll be looking at MTH 112 and we are going to dive into the applications of differentiation. Applications of differentiation. Here we are talking about maxima, minima, increasing / decreasing functions, and curve sketching. Okay, so sit tight and enjoy the video. The video is tailored towards National Open University Maths MTH 112. You can follow us if you are Open University student, or if you are interested in learning maths and understanding the concepts. This is the right place to be. So please subscribe if you're not subscribed. Share this video so that other people can see it, and let's get to it. Okay, so I have on the board this example. Where to first of all find the first derivative of this. So f prime of x is equals to, you differentiate these terms one after the other. 3 times x is 3x, and 3 minus 1 is 2. So this is the differential of this. Then this is 3, right? So we are going to set this function to be okay, let me just quickly factorize. 3 is common. So 3 outside, then x squared minus 1. So this is the first derivative of this particular function, right? Okay, so we set this derivative to be greater than 0, right? We want to test for increasing or decreasing limits. So I'm going to equate this to 0. Equate this to 0, or this to inequality. X squared minus 1 greater than 0. So we are checking. So by the time we are done, we see that there are two possible values, either that x is lesser than minus 1 or x is greater than 1. Okay, so the function is increasing where, so the function is increasing when x, which is less than minus 1, or x is greater than 1. So this function is decreasing. Similarly, it is decreasing where this range of value exists, minus 1, lesser than x, lesser than 1. Okay, so that is where it's decreasing. So this already gives us a sense of curve behavior. Okay, so the next one we'll go into is stationary points. So a stationary point occurs where f of x, that is differential, is equals to 0. So that point is stationary. When you differentiate that function first time and you get is equal to 0, it's stationary. So it is where the slope becomes horizontal, usually a maximum or minimum or inflection. So I have this like this. This is a curve. This point is stationary point. This is minimum. This point is a stationary point where f of x is equal to 0. Or inflection. Inflection is like this. The curve is changing. This point is inflection. Okay, so we're going to do an example. The same one we did the first time. If I differentiate this function and I'm getting this. Remember that first example that we did now? I'm getting this. So stationary point occurs where I equate x squared minus 1 is equals to 0. You understand? Either this is equals to 0 or this is equals to 0. I cannot use 3 because there's nothing to find. So I'm looking for this one now. So x squared minus 1 is equal to 0. By the time I do the maths, x is equals to minus 1 and x is equals to 1. So these 2 points, minus 1 and 1, are where the stationary point occur. The stationary points are x is equals to minus 1 and x is equals to 1. These are where the stationary point occurs. So once you get once you find stationary points, you can classify them using the first and second order derivative tests. That is where maxima and minima point will occur. So what's the first derivative test? The first derivative test from the name, This test actually is to just find the first derivative and look for where there is change from positive to negative. You understand? So if first derivative changes from what? From positive to negative, it is maximum. It is maximum. I will do an example of this. So if the thing changes from positive to negative is maximum, that is for first derivative test. Then if again, this is number one. Number two, if f of x, that's first derivative of x, please, changes from negative, see from negative to positive, then it is minima. Okay, so look at the sign. Positive to negative, maxima. Right? Negative to positive, minima. Okay? So I want to get you a mnemonic for this. Positive to negative, it starts from positive, right? The starting point is positive, so it's maximum. Then negative to positive, the negative is the starting point, is minima, right? So positive to negative, maxima, because starting from positive. Then negative to positive is minima instead of negative. So we're going to do, this is just the first derivative test. So take note of that while I lead you through the second derivative test. So for the second derivative test, the first thing you do is to compute. You compute that second derivative, right? F prime prime x, right? You get it. Now, if, number one condition, if f prime prime of x, or yes, of a. Now, if I put a here, it means that I'm going to be substituting a value called a into the second derivative. If I substitute that value called a and is greater than 0, understand? At a stationary point, okay, x is equals to a, then minimum happens, curve bend upwards. So this is minimum, then the curve bends upwards. Okay, so this is how this thing is playing out. It bends upwards. Okay, so f prime prime of a greater than 0. A is the minimum, is the stationary point. You understand? It's stationary point. This A is stationary point. So how do you get stationary point? Remember, when we differentiate by first principle and equate to 0, the value of x when you equate to 0 is stationary point. Remember, so that stationary point, if you put it as second derivative, you understand, and it's greater than 0, you understand, you have minimum. Now, second condition for us to also test for maximum, if f prime prime of a is less than 0, then this is maximum. Okay, maximum. So greater than minimum, less than maximum. Okay, so this is the curve bends downwards. Okay, so third test is if f prime prime of a is equals to 0, then the test is inconclusive. Inconclusive. Okay. So note these three things. Note these three things. So you can have a situation where you have this. Remember, A, you are putting A inside this derivative. A is the stationary point. And stationary point comes from first derivative is equal to 0. What's the value of x? If you put dy dx equals to 0, what's the value of x that you get from here? That value of x, if you get x is equal to 1, that 1 is stationary point. That 1 becomes A for this test of second derivative. Understand? Okay, so let's just remember that. So let's just quickly look at classifying stationary point. Classifying stationary point. So you recall the example we used to solve, where we say that f of x is equals to x cubed minus 3x, right? And if we differentiate it, we are getting 3x squared minus 3, right? 3x squared minus 3. So we found that the stationary point is at x is equals to 1 and x is equals to minus 1. We have found that one out. But when we equate this one to 0, we will get it. Remember, when we equate this one to 0, see what happens. We factorize this one, right? 3x squared minus 1, right? Either this is equals to 0 or this is equals to 0. So when we did that is equal to 0, we are getting x equals to 1 or minus 1. So this is the stationary point. So again, at x is equals to 1, at x is equals to minus 1, for instance, let me take this one for first. F prime prime, then you now put that minus 1. That minus 1 is now your A. Remember that conditions I gave. That minus 1 is now your A. The A is actually the stationary point. Stationary point. Stationary point. Remember, it's gotten from first derivative when you equate to 0. Right? Okay, so f prime prime, if you put 1 inside of it, what will you get? What will you get? This f prime prime is this one, right? Is this one. So if I put minus 1 inside that one, okay, I say 3 minus 1 square minus 3, right? So this one is sorry about that. So second derivative of this one, second derivative of this one is to differentiate first derivative. So I have it as is equals to 6x, right? Now if I put minus 1 here, for instance, what will I get? F prime prime minus 1 is equals to 6 into minus 1, right? I will get minus 6. Now minus 6, what is it in relation to 0? Is less than 0, right? Less than 0, because on this side of the, so this one now is maximum. It's maximum because it's negative. So this is maximum. So this point, minus 1 is maximum. That is, this at this point, you have maximum. I'm putting maximum here now because I've determined it by substituting that this value into the second derivative, and I see that it is less than 0, so it is maximum. Okay, so for at x is equals to 1, at x is equals to 1, understand? F prime prime of x of 1 is equals to 6 times 1, right, which is 6. And 6 is greater than 0. So this one now is minimum. So the minima is at this point. So I know that at x is equals to minus 1 is maximum, and at x is equals to minus plus 1 is a minimum. So the turning points are at maximum So concavity and point of inflection. So a curve is concave up, a curve is concave, that is up, where f prime prime of x is lesser than 0, sorry, greater than 0, greater than 0, and the concave down, this is number 1 condition, number 2 condition, concave down, where f prime prime of x is less than 0. So we should have a way of knowing this. So this, if it is greater than 0, you understand, it is concave up, right? Concave up, that is like this and like this. These are the two. So okay, so this is the condition, and this is also the condition. All right, so let's just quickly do an example. Let's say, for instance, I have f of x. Example. F of x is equals to x to the power 3. Now, if I want to get first derivative, is 3x squared, right? Second derivative, 1 is 3x squared, 6x. Okay, so if f prime of x is less than 0, when x is less than 0, it is concave down, right? Concave down. And f prime prime is greater than 0 when x is greater than 0, then it's concave up. So this is just to buttress what I have said before. Okay, so you need to sketch a curve, sketching curve. Okay, so if we're to sketch a curve from the beginning, to sketch a curve using calculus, the first thing we do is to find the domain and the intercept. Then secondly, we'll find the first derivative and determine increasing intervals. Okay. Then thirdly, we'll find and classify stationary points. Fourthly, we calculate the second derivative and the concavity. And fifthly, identify asymptotes, if any. Then draw a simple smooth curve with all this information. So it's just a matter of following the steps to get the final answer. So I would like you to go through the videos and also go through your course materials for this particular topic to gain more insights. You can contact us either by the comment section or via mail to if you have any difficulties, whether you are an Open University student, Nigerian Open University student studying maths or math-related courses, or you are just interested in this particular topic. So I hope this video has been informative for you. I'd like to thank you for viewing.